Welcome everyone to 3.1 Systems of Equations. We are in November heading towards Thanksgiving, so we got Charlie Brown themed things. Go ahead and write in. What are we thinking right now? We are thinking we are ready, okay, to start this lesson. But it doesn't look like Snoopy's ready. All right, so we got Systems of Equations today. This is a big confusion topic for a lot of students. Algebra, Algebra 2, Geometry, you'll see it in advanced topics, a senior level class. So let's go ahead and figure out what is systems of equations. What are systems of equations? Systems of equations are simply a group of two or more equations. Two or more equations. Okay, so just two more. 2, 3, 4. Now, linear systems, this is where we have linear equations, and that's in the form of y equals mx plus b, where you have x to the first power and y to the first power. No variables with fractions, or sorry, fractions with variables. And this is a group of two or more also. Okay, so solution of a system. This is something that everyone confuses for some reason. They may know that yes, it's going to be an x and a y, but what does that mean? What does this x and y mean? This is the point of intersection. Okay, it's where the two lines meet. It's where they cross each other. It's where this x value and this y value make it true for all equations. So these two values, okay, these values will make true statements in all the equations, in all equations in the system. Okay, they'll make true statements, and that's why they cross at that point. Okay, so let's go ahead and jump into some graphical examples, and then the next video we'll go over substitution, elimination, and so on and so forth. Okay, so example 1, what is the solution to the system of equations? We have a green line, we have an orange line. Where is the solutions? Well, we're going to try to find values that make both equations true. If we look at 0, 0, 0, 0 is not a solution. Why? Because it's not on the green line and it's not on the orange line. So it's not on either one. Okay, let's look at the point. What is that? Negative 5, 0, negative 5, 0. Negative 5, 0 is a solution to the orange. Okay, so this one's good for the orange. We'll change this to orange style. Let's make it orange. This one's good for the orange guy, but it's not good for the green guy. He's not touching that point. So we need to find a different point. Okay, so then we look here at the point 0, 5, and we notice that the green and the orange both touch that. That's why this is the solution. 0 as the x value and 5 paired together with that x equals 0 makes this true for both green and orange. That's why this one's not a solution, this one's not a solution. Ding, 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 there's our winner. 0, 5, because that's where the two lines cross. Okay, move on to example 2. Graph the following equations and determine the solution to the system. If you need a tutorial on graphing, I would suggest some videos that are on this channel if you'd like to be inclined to review that. Otherwise, I'm just going to kind of glaze over it a little bit. Not glaze over it, but go through it quickly. So the purple is kind of pretty much ready to go because it's already in slope-intercept form. I'm going to start with my y-intercept of 2. Okay, that's my y-intercept. And I'm going to use my slope, which is the value in front of x, which is negative 1, to graph my next point. I'm going to go down 1 to the right 1. I can do this as many times as I need. I'm just getting an idea of where it goes. And then I'm going to connect my dots. All right, so let's do this. I got one shot at this. Looks like I did pretty well. That's pretty darn good. I normally butcher that, but that's a victory for me right there. Okay, so we got my purple graph graphed. My purple equation graph. I'm going to try to get the blue one now. My issue with the blue one is it's in standard form. So I guess I can show you in standard form. I could convert it if I wanted to, but what I'm going to do is I want to find, because it's in standard form, the x-intercept and the y-intercept. Okay? To find my x-intercept, I'm going to plug in 0 for y. So essentially I'm going to cross off 2x plus 4y. I'm going to cross that off. I'm going to plug in 0 for y, which makes that go to 0. So we get 2x equals 12, x equals 6 after I divide both sides by 2. Just to show you what I did there, I get 4 times 0, and 4 times 0, because I plugged in 0 for y to find the x-intercept. That's where y equals 0. Okay, so I'm just showing you that standard form is not too hard to graph. You just basically cover it up with your finger. So you can get my little laser pointer, cover this up, and pretend it's not there because it goes to 0. And then you have 2x equals 12. You can easily find your x-intercept. So I'm going to go over here. I know my x-intercept is, what is that, 6? 1, 2, 3, 4, 5, 6. So I make a dot right there. There's my x-intercept for the blue. Okay, y-intercept, I do this exact opposite. Let me get orange. So I get 2x plus 4y equals 12. This time I'm going to cover up the x. That goes to 0 because I'm going to do 2 times 0. This is where where x equals 0 to find my y-intercept. And I get 4y equals 12. And I get y equals 3 after dividing both sides by 4. So now I'm going to go up here. I'm going to do, okay, this guy, y-intercept of 3. Make a point. Okay. Oh, I don't know why I chose that color. I should choose blue. Okay, I have 2 points. That's good enough for me. And what I'm going to do is I'm going to connect the dots here. That's a little rough. All right. I kind of missed. I did well on the purple, not so good on the blue, but I can fix it. All right. Now, I kind of have a rough idea of where the blue and the purple cross. I know it crosses right here. It helps when I have a perfectly drawn coordinate plane, which sometimes you won't. Sometimes you'll be using your book or some scratch paper and you'll have to draw it yourself. So in that case, what we should do is we should find the slope of the blue. You're like, oh, that's what I wanted to do anyway. You got to do the standard form stuff. I'm like, okay, that's fine. Calm down. We're going to do it now. So for all of you people that are complaining, we're about to do it. So I'm going to subtract 2x from both sides. You get 4y equals negative 2x plus 12. Divide by 4 to both of those. I get y equals, okay, negative 1/2 x plus 3. As you see, I got my y-intercept of 3. Now I'm going to go in reverse. So with my purple, I should probably go in reverse a few more times. That's up 1 to the left 1. I don't know if that's the same point. It might be. I think it is. Up 1 to the left 1. That's about right there. Okay. Now for my blue, I can go down 1 to the right 2. That takes me there. I'm going to go in reverse. I'm going to go up 1 to the left 2. Guess what? I all land on the same place. That's this guy right here. Okay, so that point right there, which is, survey says, negative 2, 4. And that is my solution. Now, what does that mean? This means I can plug in x equals negative 2 and y equals positive 4 into both equations, and it's going to make a true statement. Okay, now if I plugged in 0, 0, again, this is kind of like just my reference point. If I plugged in 0, 0, let's make it yellow because it's not good. If I plug in 0, 0, it's not going to make a true statement. Because then I would get, for blue, I would get 0 plus 0 equals 12. That's not true. And then for purple, I'd get 0 equals 2. That's not true. So 0, 0 is not a solution, but negative 2, 4 is. That's what it means to have a solution to a system. Let's go over some vocabulary real quick, and then we're going to end our video with, one more. So this video isn't too long. We'll keep going. If you just want to fast forward, that's fine. I wouldn't blame you. This isn't incredibly exciting stuff. So consistent system, this means that there is an intersection. There is an intersection, okay, between the lines. If there's an inconsistent system, that means there is no intersection. Okay, so let's go over the first. There's two different types of consistent systems. There's independent. That means that there is only one solution. Okay, there's only one solution. The two graphs cross and they only cross at one spot. Now, a dependent system, okay, a dependent system means they cross everywhere. They cross on the whole line because they are the same line. There are an infinite number of solutions because it's the same line. So these cross everywhere. So dependent is the same line. Independent, two different lines, but they cross. Inconsistent means that they never cross. Okay, they are parallel and they will never cross each other. Therefore, there's no solution. So this one has no solution. Okay, let's go over another example. Graph the following equations to determine what type of system it is and what the solution is. Okay, two things we need to figure out. I'm going to go ahead and just get it into slope-intercept form so I can be a little bit more accurate if it comes down to that. So I get add x to both sides. I get y equals x plus 6. So my y-intercept is 6. 1, 2, 3, 4, 5, 6. And I'm going to go up 1 to the right 1. And I'll do the same thing in reverse. Down 1 into the left 1. And my line looks something like that. Okay, close enough. All right, now I'm going to do the green, or the orange. I just did the green. One thing I notice here, everything is divisible by 2, so I'm going to divide by 2 to both sides first, just to make it a little bit easier. You can do that. It's a nice little trick if everything's divisible by the same number. I get x minus y equals 4. Psych, equals 2. I'm going to subtract x from both sides. I get negative y equals 2 minus x. And I'm going to divide by negative 1. Once I do that, I get y equals positive x now. Negative x divided by negative 1, positive. And then I get minus 2. So I'm going to start at negative 2. And then go up 1 to the right 1, up 1 to the right 1. Okay, one thing you should notice, they have the same slope. They both have a slope of 1. We have 1x in both equations. Therefore, this is inconsistent with no solutions because they're parallel and they will never touch. Okay, lastly, so pause this if you need to look at it and catch up, but we're going to move on to this table. So you can do the same thing with the table. If you're looking for the solution to two different equations, we can use a table. So number of hours a month exercising. So we started in 2015, and let's just assume that this is linear, okay? That was the start. We're doing linear systems here. So you can see 18, 19, 20, 21, 22 for men. So we're going to keep the pattern going. 23, let me make it red. I don't know, I'll make it purple, whatever. 23, 24, 25, 26, 27. Okay, so we're adding 1 each time for the men. Now for the women, what is the pattern that's going on here? Okay, we're adding 1.5. So we add 1.5 each time. So what happens here? We have 21.5. Then we have 23? Then we have 24.5. Then we have 26. And then we have 27.5. So women end up overtaking the men by the year 2024. But what is it asking? Well, if it's asking for the solution to the two different equations, we would have women would be one equation. We'd have men be the other equation. Okay? And what does that mean in terms of this problem? What would be the solution? Okay? Where would they intersect? It means where are the men's workout hours and the women's workout hours the same? And that is in year 2023. They will meet up, they'll intersect there. So that would be our answer. Where are they both the same? 2023 would be our answer. That is all we have for systems by graphing. Hopefully you learned something about the vocabulary, and stay tuned when we talk about the substitution method. See you soon.